All right, guys, this is our absolute value test review. I am going to start out by sketching the graphs of these absolute value functions. The directions ask us to sketch the graph of the following equations, then describe the transformations of the parent function, give the domain, the range, and the solutions to the absolute value equation that correspond to the function. So what we're going to do is we're going to use transformation rules to sketch the graph, and then we're going to talk about domain and range. Remember that on the test tomorrow, you will have a calculator at your disposal. So if you are having trouble doing this without a calculator, remember that you can use one on the test tomorrow. I'm going to do it without a calculator because that is easier for me, but you are allowed to graph these in the calculator and look at the table and transfer the points from the table. This is the absolute value of x plus 5. That 5 is inside the absolute value, and because it's inside the absolute value, that 5 moves this absolute value function either left or right. Inside the absolute value, remember that that value goes in the opposite direction than we would expect, so it's a plus 5. It's going to move the absolute value left 5. So our absolute values usually start at 0, 0, and they usually have a slope of positive 1 on the right and a slope of negative 1 on the left. This absolute value has moved left 5, and so I go take this vertex right here, the point at 0, 0, and I move it left 5. 1, 2, 3, 4, 5. Nothing else about this absolute value has changed, so it still has a slope of positive 1 on this side and a slope of negative 1 on that side. I'm just going to go up 1 and out 1, up 1 and out 1, up 1 and out 1, so that I can get some points. Again, up 1 and out 1, up 1 and out 1, up 1 and out 1. And I'm going to graph the other side of the absolute value. And that is the graph of absolute value of x plus 5, the blue graph. Now, the domain of any absolute value function, the domain is negative infinity to infinity. Any absolute value function has that domain, always, 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 always. The range of this absolute value function, we look at the lowest y value, and that's right here, and the y value there is 0. And then you can see that our v goes up, and it keeps going up forever. That's what those arrows mean. So the range is 0 to infinity. And I have described the transformation here, but we're going to go ahead and describe the transformation down here with the other information. And so this has moved left 5 units. And that's our transformation. And the last thing I asked you to do was identify the solutions. The solutions are where it touches or crosses the x-axis. So here the solution is x equals negative 5. All right, looking at question 2, this is negative absolute value of x minus 2. This negative right here is a reflection. And that means instead of opening upward, we're going to open downward. So instead of a V, like on number 1, it's going to be a pyramid. And then this minus 2 right here, since it's outside the absolute value, it controls movement up and down. Outside the absolute value, controls movement up and down. And it moves in the way that we would expect it to. So minus 2 means down 2. So there's a reflection, and it moves down 2. Again, the parent function, absolute value of x, looks like this. And this is a transformation on that. So I'm going to take my vertex and I'm going to move it down 2. Now this is a reflection, so instead of going up 1 and out 1 and opening the V upwards, we are going to go down 1 and out 1. Down 1 and out 1. Down 1 and out 1. We're going to do that in both directions, down 1 and out 1. And you can see that what we're getting is a V that opens downward. Now, the domain of any absolute value function is negative infinity to infinity. The range of this absolute value function is the lowest point to the highest point. Well, there is no lowest point here. Those arrows point down and they go on forever. So our range here is negative infinity, and then our highest point is -2. And that -2 is included because there's actually a point there at -2. We are going to describe these transformations. So we have a reflection over the x-axis, and this has moved 2 units down. And the last thing I asked you to identify was the solutions, and that's where it touches or crosses the x-axis. And if you look at this blue absolute value graph, it does not, and so there are no solutions. And that's because it doesn't touch the x-axis. It doesn't touch the x-axis, and that's why there's no solution. Okay, moving on to number 3, and there's a lot of stuff going on here. In fact, there are 4 transformations that are happening with this function right here. There are 4. I'm going to zoom in really far so that you guys can see my tiny, tiny numbers on the equation here. So this negative is the first transformation. The 2 is the second transformation. The -3 is the third transformation, and the 5 is the fourth transformation. And before we do anything else, we're going to go ahead and write out those transformations. Okay. I'm going to list them down here by number. So my first transformation, where that little 1 is a reflection over the x-axis. And that transformation stands on its own. The second transformation is a vertical stretch of 2. So that's the 2. And the negative and the 2 are separate. The third transformation is a number inside the absolute value. That means it's moving left or right. And remember that it moves in the opposite direction than we would expect. So here, instead of moving left 3, we're going to move right 3. And then the fourth transformation is the number on the outside of the absolute value. And that moves up and down, and it moves in the direction we would expect. So that's an up 5. All right, again, the parent function that we are dealing with is just absolute value of x. And so when we transform this absolute value function, when we graph this one, we are moving the vertex right 3 and up 5. So I start at 0, 0, and I move right 1, 2, 3, and up 1, 2, 3, 4, 5. And that's my new vertex, the turning point right here. Now, this is a reflection, which means it's opening downward, like this one right here. But in addition, we have a vertical stretch happening. So instead of going down 1 and out 1, we're going to go down 2. 1, 2, and out 1. And we're going to do that in both directions. So down 2 and out 1. And we're going to continue from these points going down 2 and out 1. 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 And you can see that the V that we're getting is significantly narrower than the V's that we got for any of the other graphs. All right, so that's a reflection, which means it's opening downward, and then the vertical stretch by 2 is why it's narrower than, for example, this absolute value right here. The domain of this absolute value function is the same as the domain of all absolute value functions, which is negative infinity to infinity. Sure, it's narrower, but it's still getting to infinity. The range of this absolute value function, it's a reflection, so we're going to start at negative infinity, and then we're going to go all the way to the highest point, which in this case is at y equals 5. And so it's negative infinity to 5, and the 5 is included. We have described the transformations, and I also asked you to give me the solutions. In this case, we're crossing not at nice, pretty points. The solution here is 1/2, and although it doesn't look like it there, the solution there is 5.5. You can give me estimates if it doesn't cross at nice, pretty points. So this is x equals 0.5 and 5.5. Those are where it crosses the x-axis. All right, moving on, let's talk about the questions down at the bottom of this page. So we're looking at this graph right here, and they want to know what the parent function for this graph is. Well, we're only studying one parent function, it's absolute value. And so the parent function for this graph is absolute value. And that's y equals the absolute value of x, like that. They want to know what transformations were applied to that parent function to produce the graph of f. And so they want us to look at this and say, well, how did it change from y equals the absolute value of x? And it might be helpful for us to graph the absolute value of x just so that we have an idea of what it looks like, so that it will help us understand what has happened. That is kind of an ugly absolute value of x. I'm sorry, guys, but we're going to live with it. That's why you don't do math in pen, right? So if I look at this, the vertex for this has moved to the right 1, because it went there, and then it also moved down 1, 2, 3, 4. And if I'm looking at this, my absolute value goes up 1 and out 1, up 1 and out 1. But this absolute value does not. Up 1 and out 1 would be here, and my absolute value is not going through that point. In fact, this absolute value appears to go up 2 and out 1, up 2 and out 1, up 2 and out 1, and that means that's a vertical stretch of 2. And so now I've identified the transformations that have happened to this absolute value. What I can do is I can take those transformations and write an equation. Vertical stretches and reflections go in front of the absolute value. Right and left goes inside the absolute value, and up and down goes outside on the end of the absolute value. So my graph here, or my equation, is 2 times the absolute value of x. Now it's right 1, but remember the inside number goes in the opposite direction than we would expect. So instead of x plus 1, it's x minus 1. So 2 times the absolute value of x minus 1, and then down 4, and that looks the way we think it should. So that's a minus 4. So here's your stretch of 2, right 1, and down 4. All right. The next 2 problems give us a verbal description of the graph and ask us to write an equation of an absolute value that follows that verbal description. So given the function f of x equals absolute value x, write a function named g whose graph represents a reflection over the x-axis, followed by a vertical stretch by a factor of 2, and a translation 7 units left and 5 units down. Okay, so I am counting, and I count 1 reflection, 2 vertical stretch, 3 is the 7 units left, and 4, 5 units down. And that sounds an awful lot like number 3, where we labeled the 1, 2, 3, 4 transformations, right? And so if you come back and look at number 3, our negative is the reflection, the 2 is the vertical stretch, the 3 is movement right, and the 5 is movement up. Okay, and so that's 1, 2, 3, 4 things. So let's come back down here and let's write this equation. So a reflection means it's negative, so y equals negative. A vertical stretch by a factor of 2 is just a 2 in front of the absolute value. A translation of 7 units left, that's inside the absolute value bars, so it's x, and remember, if we're going left 7 units, we're going to add 7 because that moves in the opposite direction than we would expect. So instead of minus 7, it's a plus 7. So absolute value of x plus 7, and then 5 units down, that's going to go in the direction we expect, so minus 5. And that's our equation. So reflection, a stretch, 7 units left, and 5 units down. Oh, and I'm sorry, I didn't name this function correctly. That's a y, so this is g of x, like that. It says, given the function f of x equals absolute value of x, write a function named h of x, whose graph represents a vertical compression by a factor of 1/3, that's one thing. A translation 8 units right, that's a second thing. And 6 units up, that's a third thing. Now I don't see any reflections, so we're not going to make this negative. Compressions and stretches are opposites, but they go in the same place. So while I had a stretch of 2 here, here I'm going to have a compression of 1/3, so I write a 1/3. Now I'm going to name this one correctly from the start. So this is h of x. And so a compression of 1/3 is 1/3 absolute value. Translation 8 units right. So x, and remember it goes in the opposite direction than we would expect. So it's x minus 8, and then 6 units up is plus 6. And that's our second absolute value equation. All right, guys, I'm going to pause here, and I'll post another video that has the next page. So I'm going to make 3 videos for this. Make sure that you're working through this review, and make sure that you work through the next 2 pages and come back and check your answers.